You push the button. A violent whoosh echoes through the tiny bathroom. Your waste vanishes in less than 2 seconds. But where does it actually go when you're 6 miles above the Earth? Most people think they know. They're wrong. What really happens when you flush an airplane toilet involves vacuum technology so powerful it could rip the toilet paper right out of your hand, a mysterious blue chemical that's not what you think it is, and a waste management system that operates under conditions that would break regular toilets instantly. The truth is way more fascinating than the myths. Every commercial airliner carries what's essentially a flying septic system. But unlike your home toilet that relies on gravity and water pressure, airplane toilets face impossible challenges. At 35,000 feet, the outside air pressure is so low it would cause regular plumbing to explode. The temperature outside hovers around minus 60 degrees Fahrenheit. Weight restrictions mean every ounce matters. And here's the kicker. These systems have to work flawlessly while the plane banks, climbs, dives, and hits turbulence that would send water flying everywhere. Most people assume airplane waste just gets dumped overboard during flight. That's been illegal since 1975. Others think the blue liquid is just colored water. Wrong again. The reality is that airplane toilets use a completely different technology called vacuum waste systems, and they're actually engineering marvels that solve problems most people never even consider. The blue stuff? That's a carefully formulated chemical cocktail designed to handle biological waste in ways that would surprise you. Let's start with that flush button you pressed. The moment you push it, you're not releasing water like at home. You're opening a valve that connects your toilet bowl directly to a vacuum system running throughout the entire aircraft. This isn't just any vacuum. We're talking about a pressure differential so intense it creates a suction force of approximately 15 pounds per square inch. That's enough force to lift a bowling ball. The whole system starts with differential pressure valves located throughout the plane. These aren't simple on-off switches. They're precision-engineered components that can instantly create and control vacuum pressure while maintaining cabin pressure integrity. One valve failure could theoretically cause rapid decompression. The vacuum lines themselves are made of reinforced stainless steel and run through the aircraft's belly, connecting every bathroom to a central waste tank. These aren't your average pipes. They're built to handle not just waste, but the extreme pressure changes, temperature fluctuations, and vibrations that come with flight. But here's where it gets really interesting. The waste doesn't just get sucked away into nothing. It travels through a network of pipes at speeds approaching 60 miles per hour, guided by a series of check valves and flow controllers that ensure everything moves in exactly one direction. The engineering tolerances here are incredible. These pipes have to maintain perfect seals while dealing with pressure changes that would destroy regular plumbing in seconds. The central waste tank sits in the aircraft's lower compartment, and it's not just a simple container. It's a pressurized, temperature-controlled vessel made from aircraft-grade aluminum with internal baffles designed to prevent waste from sloshing around during flight maneuvers. Each tank can hold between 200 and 300 gallons, depending on the aircraft size. Now let's talk about what most passengers never see or understand: the blue liquid, and what actually happens to your waste after that powerful flush. That blue substance isn't just colored water or a simple disinfectant. It's a complex chemical formulation called Anotech Aqua K, and its job is way more sophisticated than just making things smell better. The blue color comes from a dye, but that's just for identification purposes. The real magic happens at the molecular level. This chemical contains biocides that break down organic matter, enzyme inhibitors that prevent bacterial growth, surfactants that help with waste breakdown, and most importantly, formaldehyde-based compounds that actually preserve waste in a way that prevents decomposition during flight. Why does this matter? Because airplane waste tanks aren't just storage containers, they're temporary preservation systems. The waste has to remain stable, odorless, and manageable for potentially 12 to 16 hours during long international flights. But here's what really happens when you flush. The vacuum system doesn't just suck everything away randomly. There's a precise sequence. First, the flush valve opens for exactly 4 seconds. No more, no less. During this time, a measured amount of the blue chemical gets injected into the bowl, along with a small amount of water. The vacuum then pulls everything through the system at tremendous speed. But here's the part that will blow your mind. The waste doesn't go directly to the storage tank. It first passes through a separator system that removes excess air and ensures only liquid and solid waste continues to the tank. The separated air gets filtered and vented, while the waste gets mixed with additional chemicals in a pre-tank chamber. This whole process creates what's essentially a slurry that's designed to remain stable and manageable until the plane lands. The engineering precision required here is staggering. The system has to measure exact chemical ratios, maintain vacuum pressure, control flow rates, and do all of this while operating in an environment where temperature and pressure are constantly changing. The biggest myth people believe is that planes dump waste overboard during flight. This creates those infamous stories about frozen waste falling from the sky, what the aviation industry calls blue ice incidents. But here's the truth. When blue ice does fall from aircraft, it's not from intentional dumping. It's from system leaks, usually from faulty seals around waste tank connections or damaged vacuum lines. These leaks allow the blue chemical to escape and freeze on the aircraft's exterior, sometimes breaking off during flight. It's rare, but it happens. Another major misconception is that airplane toilets are somehow less sanitary than regular toilets. Actually, the opposite is true. The vacuum system and chemical treatment make airplane toilets incredibly hygienic. The powerful suction prevents splashback, the chemicals actively kill bacteria and viruses, and the entire bowl surface gets cleaned with each flush. But these systems aren't perfect. The most common failure point is the vacuum generator itself, a complex pump system that creates the suction pressure. When these fail, toilets become unusable until ground maintenance can replace components. Another frequent problem involves the flush valves. The precision timing mechanism can malfunction, causing either weak flushes that don't clear waste properly or continuous flushing that wastes chemicals and creates noise complaints from passengers. The worst failures happen when waste tanks overfill or develop leaks. An overfilled tank can cause system backups that affect multiple bathrooms, while leaks can create pressure problems throughout the aircraft. Temperature extremes also cause issues. The blue chemical can actually freeze in the lines during high-altitude flight, blocking the system entirely. Airlines have to use specially formulated antifreeze chemicals in cold weather operations. So now you know the truth. That innocent flush button triggers a precision-engineered system that's actually more complex than most people's entire home plumbing. The vacuum technology creates suction forces that rival industrial equipment. The blue chemical isn't just soap. It's a carefully formulated preservation system designed to handle biological waste in conditions that would destroy regular toilets. The waste doesn't disappear into thin air. It gets processed, treated, and stored in pressurized tanks until the aircraft lands. When the plane reaches the gate, ground crews connect specialized service vehicles to drain the waste tanks through sealed systems that prevent any spillage or contamination. The waste then gets transported to treatment facilities just like regular sewage. The blue chemical gets neutralized, the organic matter gets processed through standard waste treatment procedures, and the water gets purified. The empty tank gets cleaned, disinfected, and refilled with fresh blue chemical for the next flight. This entire system represents decades of engineering evolution, solving problems that didn't exist until humans started flying long distances at high altitudes. Every component, from the pressure valves to the chemical formulations, had to be invented specifically for aviation use. The result is a waste management system that's more sophisticated than what most cities use for sewage treatment. Next time you're on a plane and you push that flush button, remember, you're not just using a bathroom, you're operating a piece of aerospace technology that combines vacuum engineering, chemical processing, and precision manufacturing into a system that works flawlessly 35,000 feet above the ground. The violent whoosh you hear isn't